Okay. So this is the starting point I gave you, right? All right, so we have this function called binaryToDecimal. Actually, just out of curiosity, how many of you got this working the way you got this working in a generic way that we can call it multiple times, passing it multiple different things? Four? I get not 4.5 people. 4.5 people. So the rest of you found it struggled with it, right? Okay, and that's okay. That's somewhat expected at this point. All right, so we're naming our function binaryToDecimal. It's going to take a single input bin. So the first time we're calling it here, bin will be this guy. The second time we're calling it here, bin will be this guy. Okay, so for right now, go ahead.
Do you want to print it within the function? Because I did the
print this guy?
I changed it to return something.
Which is fine. Yeah, returning something or printing, we're actually going to talk about returning things today. Unimportant. If you did it that way, that's fine. Yeah, because you've had some programming before. So this is probably your first chance where it's like, okay, this is actually programming, sort of, kind of. All right. So in any case, we take in a parameter bin, and now we're going to need a couple of variables. What I've given you already is I said, here's place. Okay? And then we need a loop. So in our example here, let's just take this guy away. We want to be able to loop through every character in this string. Okay, what I showed you at the end of class last time is how to access an individual character in a string. All right, so we're going to start with the length of bin, which in this case is 5. Okay, so if I add more things to it, now the length of bin is 6, 7, 8, 9, 10, so on and so forth. Okay, but right now the length of bin is 5 in this example. So this will be 5. We're going to count down to 1, and we're counting by -1 each time. So this will go 5, 4, 3, 2, 1. Okay? And each time through, what am I doing? I am printing the letter at position I in bin. So I'll print out the letter at position 5, which is a 0. Then the letter at position 4, which is a 1. Then the letter at position 3, which is a 0. 2, 1. Make sense? That's what the code does right now. This loops through every character in bin. Actually, what it does is it loops through the number of characters in bin number of times. What I do in here is access each of those individual characters by saying, give me the letter at position I in bin. All right, so this should display 0, 1, 0, 1, 1, 5 separate times. So there's the 0, there's the 1, there's the 0, there's the 1, and there's the 1. Okay? That's what this does right now. Similarly, I can print out just I. So let's experiment with this a little bit. This should print out 5, 4, 3, 2, 1. Proving that this loop is counting I starting at 5, going down to 1, subtracting 1 each time. So there's my 5, my 4, my 3, my 2, my 1. Okay? Now, again, putting this all into some context for us. Remember back in the beginning of the semester, we talked about how human beings solve problems. We remember things, memory. We ask questions, and we have repetition. Already right here, we're remembering 2 things. We're remembering place and we're remembering bin. And here's some repetition. Inside of here, we're going to have to ask some questions too. Okay, because we only want to do something if we're looking at a 1 in our string. All right, but we do need to now do something to place. Okay, and this is where a lot of people struggle. So like you were saying, you had to hard code in place is 1, now place is 2, then place is 4, then place is 8, so on and so forth, right? What I'm going to do here is we're going to set place equal to whatever place is currently equal to times 2. Okay, and each time through the loop, before we change it, we're going to print out place. So in this case, we have 5 characters. So we're going to go through this loop 5 times. We're going to print out 1, 2, 4, 8, 16. The values of place. Does that make sense? And each time through the loop, we're changing place to be equal to whatever it used to be equal to times 2. Rather than hard coding each individual place in there. All right, so we're going to print this and prove that place is changing the way we want it to change. So what we're doing is we're kind of writing all these little tiny baby steps and seeing how these variables change. Then we're going to put these guys together into the actual logic for this problem. Okay, so we'll print this. It's going to print, we'll play this. It's going to print the original value of place, which is 1. Then place becomes itself times 2, so that's 2. Next time through the loop, it'll print out a 2. 2 becomes 4. Next time in the loop, it'll print out a 4. 4 becomes 8. Next time, it'll print out an 8. 8 becomes 16. Last time through, it'll print out a 16. 16 becomes 32, but the loop is now over, so we won't print out the 32. There's the 1, the 2, the 4, the 8, the 16. Make sense? So that's showing place going through the values that we want it to go through. Okay, so now we need to put all those things together. We have place doing what we want it to do. We know I is doing what we want it to do. We know that we can access the individual characters of our string, doing what and getting each of those individual guys. Now we need to decide what questions do we need to ask. Okay, so here's like our example from last time, 1, 1, 0, 1, 0. So notice we start off at the 1's place, the 2's place, the 4's place, the 8's, the 16. So we start off at the right-hand side here. 1's place, 2's, 4's, 8's, 16's. And every single time we see a 1, we're adding this to our running total. Does that make sense? Here I see a 0, so I'm adding nothing to my running total because 0 times 1 is 0. Then I'm adding to that 1 times 2, 2. 0 times 4, 0. 1 times 8, 8. 1 times 16, 16, to give us the 26. So I might say I need to store this answer inside of a variable maybe called total. Okay? And whenever I see a 1 stored in my string, so this is a 0, I'm going to do nothing. This is a 1, so I need to add place to my running total. When I had a 1 right here, 1 times 2 is 2. Place was actually 2. So I added a 2. 0 times 4, so place was 4, but this was a 0. Place is now 8, add an 8. Place is now 16, add a 16. So I can actually do the math if I want, but why not just notice that every single time I see a 1, I need to add the current value of place to my running total. Do I see a 1? No. Do I see a 1? Yes, add 2. Do I see a 1? No. Do I see a 1? Yes, add 8. Do I see a 1? Yes, add 16. Okay? The 2 times I didn't add was when place was 1 and when place was 4. Because 0 times 1 is 0, 0 times 4 is 0. So I have bin, I have place, now I need another variable for total. Or whatever you'd like to call it. And we'll start total off at 0. All right, so now we're interested in asking a question. We know that every single time through the loop, we do need to double place. So we're going to leave that line in there. But now we need to ask a question. Whenever we're looking at a 1 in our string, whenever the current character is a 1, we want to do something. What do we want to do? We want to add the current value of place to the current value of total, storing the result back in total. So I need to ask a question. So that's under our logic. Here's our questions. We'll put it in here. Okay, I need to access the individual character, which that was given information for us. That was part of what I handed to you. So here is our text. We're interested in the variable bin because that's our input. So bin, we're interested in the letter at position I. Because remember, this loop takes I on a voyage between the length of bin, which in this example is 5, down to 1. 5, 4, 3, 2, 1. So this will give me the character at position 5, then the character at position 4, then the character at position 3, so on and so forth. Okay? And what do I want to do with that? I want to check to see if it's equal to a 1. Does this guy equal a 1? That's the question we want to ask. If the character at bucket I in bin that we're currently looking at, if it's equal to a 1, what are we going to do with it? We are going to set total equal to whatever total is currently equal to plus whatever place is currently equal to. Okay? But we only do that if we're looking at a 1. If the current character we're looking at is a 1, we're going to add place to total, storing the result back in total. Regardless of whether we answered yes to this if statement, we will always double place. Place will always go from the 1's place to the 2's place to the 4's place to the 8's place, so on and so forth. Okay, when all is said and done, when this loop finally ends, our answer should be built up in total. Okay, it should be built up in total, so we'll go ahead and print total. Okay? So here's my function that I wrote that should work on any binary number I pass into it. It starts place off at 1 because we always start at the 1's place. Starts total off at 0 because we haven't added anything to it. We're going to loop through all the characters in our input in bin, starting at bin's length, so starting at the end, and going all the way to the beginning, stepping by -1 each time. Each time through, we're going to ask the question, if the current character we're looking at is equal to a 1, then add place to my running total. Regardless of whether it was equal to a 1 or not, make sure place moves to the next place. After I've done that for every character in my string, I'll exit this loop, and the last thing I'll do is print out total. So this current guy should be, what, a 26? So there's my 26. If I want to change this to another number, 3,435. I can call this multiple times, passing it different values. 101. So there's our 3,435, and there's our 5. Make sense? So now we've written a generic solution, a function that we can call multiple times. Okay, it's a reusable chunk of code that we can call over and over again, giving it different inputs, and this guy will work on any of those inputs. All right, make sense how this worked? Okay, so now for most of you, it should be a lot clearer when you see it than being able to write it yourself. Is that a true statement right now? Okay, So let's kind of walk through this and see how these variables build up. Because this is kind of the part in the course where we really need to focus in on drawing pictures. Because what's going to happen is we can only, as beginning programmers, we can only conceptualize so much in our head. Okay, eventually you'll be able to sit down and just write this in a couple of minutes because this isn't a hard problem in the big scheme of things. Okay, but when you're first starting, even keeping track of a couple of variables and how the values change in those variables becomes kind of a daunting task, right? Because one thing's going from 5 to 4 to 3 to 2 to 1, another thing's going from 1 to 2 to 4 to 8 to 16, then we're accessing characters in the string. There's kind of a lot of things going on for a beginning programmer, right? So let's kind of look at how these things play out in our picture here. So I'm going to get rid of most of this stuff here, and we're going to actually write our variables. So we have bin, and in this case, bin is 11010. Okay, so that's our input. That's the thing that gets passed to our function. Then we have place, and place starts off at 1. And then we have total, and total started off at 0. These are the 3 pieces of things that we need to remember to solve this problem. At this point, we're solving the problem as people. We're using our memory to solve this problem. We need to keep track of these 3 things. Okay? So those are the 3 things we need to remember. Now, we need to go through every element of this string. Somehow. As a human being, we know if we're going to go through it backwards, we'll hit the 0 first, then hit the 1, then hit the 0, then hit the 1, then hit the 1. We'll figure out the programming construct to do that later. But we know that that's what we need to do. Okay? So start at the end of bin and walk to the beginning looking at each character. Okay? So that's what we're going to do. Now we know that, well, first of all, we have to understand the problem. So we have to first understand how to convert this number into decimal. So each time through, we're going to walk and we're going to look at the current character. And if it's a 0, we're going to multiply 0 times place and add it to our running total. If it's a 1, we'll multiply 1 times place, add it to our running total. So really what we're going to end up with here is something that looks like this. 0 times 1, where place is 1, then place becomes 2. Plus 1 times 2, place becomes 4. Plus 0 times 4, place becomes 8. Plus 1 times 8, place becomes 16. Plus 1 times 16, place becomes 32. And we now have no additional characters to look at. We've dealt with every single character inside of bin. Make sense? Now, as we go through here, if we kind of itemize these out, we see this is 0 plus 2 plus 0 plus 8 plus 16. These zeros are wastes of time, correct? We don't need those zeros. So we could say, well, when did we run into zeros? Well, whenever we hit a character in our string in bin that was a 0, we don't need to do math. We don't need to add anything. We're wasting our time adding a 0 onto our total. Does that mean adding 0 onto the total is wrong? Oh, it's perfectly acceptable. Might be actually interesting to see how this guy handles doing math with strings. Okay, so we'll actually look at it here in a second. Because really what we're doing is we're always taking this value and multiplying it by this value and adding it to total. That's what we're doing every single time through. So it might be interesting to see how does it handle if I access this guy here, get the character at that position. Can I do math with that 0 and give myself a 0? Or is it going to yell at me and say, the value for place times the string 0 is undefined. Okay, so that's something we're going to have to look at Blockly and see how it converts JavaScript into that. So let's actually look at that real quick. That would allow us to get rid of the if statement. So now what we would do is we would set total equal to total plus, now we're going to need another math formula here. This guy. Getting too close to the garbage can. Oh, yep, it doesn't like working with text in there. Can't do math with the text. Can we convert it? I don't see an obvious way to do math with text.
I did it set a variable to in text get letter. So I mean the type.
Oh, as long as you put the type into a variable, then you could do math with it.
Right. So I don't know how it would work in the actual. Like,
Got it.
Issues with Python the other day.
Right. So what he did is he maybe created a variable up here called temp. Just call that temp. And we could start it equal to whatever we want. We'll just start equal to the empty string. We're going to overwrite it here. We'll go ahead and get rid of this if real quick. And then what we'll say is we're going to set temp equal to the text at bucket I. Then we'll set total equal to total plus temp row times place. So now, rather than asking a question, we're just setting a variable equal to the current character, and then setting total equal to whatever total currently is, plus temp times place. And you're telling me that let you do the math this way? Okay. So temp is holding a string. And we weren't allowed to put a string in here directly. It yelled at us. Blockly didn't allow us to put a string in here directly. But we were able to put it inside of a variable called temp. And now we're taking whatever's in temp and multiplying it by place. So it must convert that into an integer because we are doing math. So it must assume we mean the integer version of these guys. So with this in mind, we should get the correct answer. There's that, and there's the 5. So we're getting the correct answer without asking a question because we're literally just doing the math. 0 times place or 1 times place. That make sense? 0 times place is 0. We'll add it onto our total. It made no effect, but we didn't have to ask a question. Okay? Now, so we look at the JavaScript version of this. Here is the total equals total plus temp times place. This is that logic right there. And here's temp is equal to the current character. Yeah, so this actually has to be something dealing with JavaScript. Let's look at the Python equivalent. Let's see if Python works the same way. It's producing the same code, but let's look to see if Python will allow us to take the string 0 or the string 1 that's stored in temp and multiply it by place. Okay, so I'm going to run this Python program real quick. Yeah, doesn't like it. Binary to decimal. Unsupported operand type for plus, an int, and a string. Doesn't like adding those. So another interesting thing, the difference between those. It's actually kind of almost shows us a weakness of Blockly a little bit, because I don't see an obvious way of converting a character. Well, it looks like it supports two types, numbers and strings. So I don't see an obvious way of converting a string into a number. Okay, JavaScript seems like it just does it automatically. So we're leveraging the fact that the JavaScript programming language treats temp times place as a mathematical function. Therefore, whatever temp holds, it will actually do the multiplication with place. Okay, where if we were doing this in Python, we actually would need to convert temp to a number first. And it doesn't look like Blockly has the ability, at least not seemingly. If we look at, here's our collection of text things. Yeah, it doesn't look like we can get something there. We can't take a number out of it. If we go to math, I don't think I saw anything in here. Maybe one of our functions. No. It's round. Yeah, it doesn't look like we have a facility for converting a number into or a string into a number. Okay, so kind of part of the matrix that we have to work with within Blockly. Okay, so for us, this is a reasonable solution because it did work in JavaScript. Okay, but from a programming perspective, we can notice here that this worked in JavaScript. It did the math the way we wanted it to do the math, which actually makes the next exercise we're going to look at that much more difficult. Okay, it'll make it easier in JavaScript, but if we were doing it for Python, we'd have a problem. JavaScript's going to support what we're going to do next. Okay, so in any case, getting back to our code here, this guy. Whenever we see a 0, we can just go ahead and ignore it. Otherwise, we can, the way we have the code written right now is we always just do the math. Whatever character we're currently looking at, multiply it by place, add it to total. Whatever character we're currently looking at, multiply it by place, add it to total. Whether it's a 0 or a 1, we're just doing the math. Okay? Ultimately producing our final answer, which will get stored inside of total. So total will start off as 0, we'll add a 0. Then we'll add a 2, so now it's a 2. Plus 0, still a 2. Plus 8, now it's a 10. Plus 16, now it's a 26. So in the end, total went from 0 to 0, to 2, to 2, to 10, to 26. And then in the end, we finally print out our answer because we've run out of characters to look at. And that's what this logic says to do. Make sense? All right, so any questions about this homework assignment now that you've kind of seen a solution? All right, so now let's look at another version of our functions that he mentioned earlier. So the function we're using right now is this do something one. There's a second version that actually returns a value at the end. Right now, we are printing our final value. Okay, we're printing it here. But what I'm going to do here is I'm going to go ahead and grab our function here. We'll call this guy bin2dec. He's going to take in a bin as a parameter. Okay, And I'm actually just going to take, can I grab it all in one chunk? Here we go. I'll take all that code and bring it over there. We'll get rid of this. So here's bin to desc, takes in bin, does all the stuff we did before. But now, instead of printing total at the end, we're going to return total. Okay? And then we'll go ahead and make a call to our bin to desc. And we'll go ahead and pass it a number. Good enough. Okay, so this is the ones place, the twos, the fours, so that's 6. 8s, 16s, this is 22. We run this, we get no output. Okay, why? Because I'm never actually printing the result. I'm returning the result, so this guy right here boils down to total. If I want to see it displayed, I have to print it. That makes sense? So now I'm capturing it and then just printing it. So there's my 22. Similarly, I could create a variable, maybe called answer, and I can set answer equal to whatever is returned. Okay. Again, this is going to have no output. I'm taking the returned value from my function and I'm storing it in a variable, but I'm still never displaying that variable. Okay, no output. But I can now call print and print out answer. And now I'll get my 22. Make sense? So what we're looking at there is the difference between returning a value and displaying a value. In modern programming languages, okay, we kind of talked about the history of programming languages in here. Looks like I got to restart Keynote. It's in a bad mood. Okay, so we're going to call this guy functions in C, our older language. Remember, we had our kind of the history of our programming languages. We had C, which led to C++, and then kind of had to spill through from there. In older languages like C, we actually had two separate types of functions. Well, two separate types of, let's go with an older term, subroutines. They used to be called subroutines. Okay? We had functions and we had procedures. Functions were reusable chunks of code that returned a value. Procedures were reusable chunks of code that did not return a value. Okay? In an older language like C, this makes plenty of sense. And even in newer languages like Python, JavaScript, these languages, loosely typed languages, this also makes sense. Now, if I jump ahead one slide here, and we say functions in C++ on, let's just say that, we no longer had functions and procedures. Now we have this idea of methods. Okay, methods are reusable chunks of code that may or may not return a value. Now, the reality is most of our modern languages that support this concept of methods must define the kind of value that's going to be returned. The problem we have is in the languages like Blockly, we don't have a such thing as types. Part of that is because Blockly outputs to loosely typed languages. Okay, remember the difference between a loosely typed and a strongly typed language is that loosely typed languages do not require us to define the kind of value that's stored in a variable. Strongly typed languages do. So here in Blockly, when I create a variable, set something equal to something, I don't have to define what kind of value this variable is built to hold. I could just put something into it. And a few minutes later, I could put something else into it. It doesn't care because this guy exports to loosely typed languages that also don't care. Notice in JavaScript, when I define variables, I just put the keyword var in front of them. In Python, when I define variables, I don't even put anything in front of them. Okay? Dart uses the keyword var. Okay? But it's a var, not int, or char, or boolean, or string. Generic var. Put whatever you want in there. Okay? So from a historical significance perspective, we used to have kind of two distinguishing ways of looking at functions. And I'm using these two words separately. So we can call this subroutines if we want. But we had two different ways of looking at reusable chunks of code. We had one way, which was called a function in C, which had its own syntax. And these were guys that returned a value. And then we had another guy called a procedure, which had its own syntax. And these were guys that did not return a value. Okay? In most of our modern loosely typed languages, like JavaScript, like Python, notice JavaScript, we just have this concept of function. And at the very end of this function, we happen to return a value. But when I use the other version that didn't return a value, it still would have been defined as a function. Okay? So JavaScript does not differentiate at the actual syntax level between things that return a value and things that don't. Blockly did just because it had to give us a puzzle piece to put in the return value. Okay, it had to give us a way to put that return value in. Similarly, Python, instead of saying function, we just have this idea of a def. We're defining this, defining this, defining this. Okay? This is the one we actually defined. These got defined for us as part of what Blockly produces. Okay, but here's our actual function, binaryToDecimal, that takes in a single input and then does all our logic. Dart uses something here called dynamic to define a function. This one happens to return something. But notice that most of these languages, so just look at that for a second. So notice we have variable names, we have curly braces, if statements, things like that. Compare that to the logic here in Python. Not necessarily horribly dissimilar. Compare that to here in JavaScript. Really, JavaScript and Dart look very similar. Python tends to omit the curly brace stuff because one requirement in Python is this indentation. So in Python, this line of code belongs to this function here because it's indented under that function. If it wasn't, if this guy didn't have these spaces here, it wouldn't be considered to be part of that function. So Python looks at indentation to determine when things start and stop. Most of our modern languages don't rely on indentation. Most of our modern languages rely on you creating code blocks. This is where the if statement starts. This is where the if statement stops. Okay? So when we look at Java next semester, which really has nothing to do with JavaScript, they just happen to both be ancestors of, well, they both happen to be evolutions of the C programming language. Java will look very similar to this with the curly braces and all that. Do you have a question?
Well, I was going to ask, so Python is like a reverse paragraph as opposed to Java just being parentheses, this is what it is, and close parentheses.
Well, I mean, if we look at it in here, let's just look at it in, let me do it here real quick. This really just becomes more of a caveat of different programming languages. So JavaScript would say, do something with an opening curly brace, do some things, and a closing curly brace. That would be the JavaScript version of that. The Python version of that doesn't have curly braces. But what it does require is that that part is indented under this. JavaScript, we could have everything left justified. I don't encourage this because I think indentation is important just so you can kind of see the structure of your code. But in JavaScript or Java or C# or C or Objective-C or Swift or almost all of our modern languages follow, this is kind of the C syntax thing. So they encourage you to indent, but they don't force you to indent. In fact, in these languages, you can put everything on one line if you'd like. That is a legal line of code in our modern languages. Because the way that the compiler works, when it reads through your text and parses it, it's looking for this opening curly brace to signify the beginning of a code block. It's looking for this closing curly brace to signify the ending of a code block. So on and so forth. That kind of makes sense? Okay, so it has to do with how the Java compiler or how the JavaScript interpreter, how these tools read the language and pull out the pieces. Python takes a little bit of a different approach. It says, okay, well, we're going to require the programmer to maybe write a couple of less symbols. You don't have to put in the curly braces, things like that. But guess what? If you don't indent, your code's going to have all sorts of problems. Because now we determine the beginning of the code block being whenever you indent. And we know the end of that code block is when you stop indenting. So both of these lines here are part of the code block under this do. This guy here is not. He's a brand new code block that started. So Python does this all based on indentation. Okay. One is not better or worse than another. What I'm really showing you here is kind of the differences between some programming languages. And remember, way back at the beginning of the semester, we talked about that programming is programming regardless of the language. Okay, so this kind of plays into this idea that all languages, all programming languages provide us a facility for memory, provide us a facility for asking questions, provide us a facility for loops, as well as all programming languages are going to follow a structure of some type. Most of them follow the structure that C kind of provided. But some of them do deviate from that a little bit, but still have a structure for the same reason. Okay, Python interpreter just doesn't look for curly braces. Therefore, since it doesn't look for curly braces, it has to look for other ways to determine when you're starting something new and stopping that. Make sense? Okay, just a caveat to the language, and when you start learning different languages, it'll become clear to you that you just have to kind of go into that mode. I think I mentioned last time on a given day, I might be using Python, Ruby, JavaScript, Swift, Java, Objective-C. Those are probably the common ones, I guess, on a given day. And most of those have a very similar pattern to them. But when I am working with students in Python, I have to switch to Python mode. Okay? So if I'm not in Python mode, I might forget to indent or something like that, which is a very good reason why you might want to have a habit of always indenting your code. If you're always indenting your code, really these curly braces are just for show. So all you have to do for Python is just don't write the curly braces. Everything else stays indented. That makes sense? Okay. So what we were just talking about is this. Okay, so for Monday, I'm going to give you a small homework assignment. That is a little modification of the assignment we did today. Use this as your starting point. Okay, so we're going to do one that returns a value. I want you to practice and see the difference between something that returns a value versus something that just displays something. Write a function called Octal to decimal that takes in a parameter representing an octal number. That is a base 8 number. Okay? Converting between decimal or binary to decimal and decimal to, or converting between binary to decimal and octal to decimal is identical, except for the places. Still start off with a 1 place, but then we go to the 8's place, then the 64's place, so on and so forth. So we're not multiplying by 2, we're multiplying by 8. Okay, so modify this code to now convert between an octal input to its decimal equivalent. Some of you will finish this in 3 minutes. Some of the rest of you might need to process a little bit to understand what's going on here. Okay? I will see everybody on Monday.